We're going to be looking at example 5, part A, in your section 4.3 notes. We're going to be using the test for concavity to determine where our function is concave up or concave down, and also we'll identify any inflection points. So running through the test real quick, it's about our second derivative. If our second derivative is positive, then we're concave up. If our second derivative is negative, then we have this, concave down. And if our second derivative changes sign at a value in our interval, then we have what we call an inflection point. Okay, so first up, we need to work our way to the second derivative. So first derivative here is negative 4x cubed minus 6x squared plus 24x. Okay, and then taking the derivative again, we'll have negative 12x squared minus 12x plus 24. Okay, in order to see where the second derivative is positive and negative, we're going to first find where the second derivative is equal to 0 using a little factoring here. Okay, so taking out a negative 12, we're going to get x squared plus x minus 2 equals 0. All right, factoring. We want to multiply to negative 2 and add up to the middle number of 1. We're going to get an x plus 2 and an x minus 1. Okay, so we get two possible inflection points at this stage. So negative 2 and 1 are two possibilities here. Okay, so our second step in this process is to put these values on our number line. And our domain for our function is definitely all real numbers since it's a polynomial. I'm going to put negative 2 and 1 on there. And we're testing the second derivative, so for signs. So probably the easiest value to test is 0 since it's right here in the middle between negative 2 and 1 in the middle somewhere. So you can go back to your function. You're going to have negative no matter what to start. If you plug in 0, you're going to get a positive 2. And if you plug in 0, you're going to get a negative 1. So you're going to have a negative times a positive times a negative. So you're going to end up with a positive value if you plug in 0. Okay, we'll do a similar thing for something like negative 3. If you plug in negative 3, you're going to get a negative times a negative times a negative. So that's going to end up being negative. Okay, plug in something like 2 over here. You're going to get a negative times a positive times a positive, so that's going to end up being a negative there, okay? All right, so from this we can draw our conclusions about our intervals where we're concave up and concave down. So the positive here means that our function f is concave up. Okay, sometimes I do this notation from negative 2 to 1. Okay, and then f is concave down from negative infinity to negative 2 and on the interval 1 to infinity. All right, we also have two inflection points because we have two places where it changes signs. So we change signs here and also at here. So negative 2 and 1 are inflection points. So f has inflection points. Okay, so I'm going to need to find the y values for those. Okay, so I went ahead and entered the function into my graphing calculator here. So this is the original problem that I'm trying to find the y values for. And I go to my table. Okay, so I'm looking for negative 2 at this stage. So I can see that negative 2 has a value of 48. And then 1 has a y value of 9. So I'm going to go ahead and enter those into my answer box. So negative 2, y value of 48, and 1 had a y value of 9. And that completes this part of the problem.